The company has raised $67 million in venture capital money. You are the CEO for Weaviate, which is an exciting company in the exciting field of vector databases.
The big question that you always ask is, what's the unique use case? I mean, you can store that in an old Oracle database. So the uniqueness sits in the index. I went to Google I/O. That Sander Pichai said, we're going to move from mobile first to AI first.
From a mobile first to an AI first.
I was like, I know what you're doing. So that was when we started Weaviate. Nobody called it vector database back then. And then people were like, we want to do our own data. But I can tell you, it was a long journey. This was not overnight. Value of open source right now is $8 trillion. You can capture some of that value in the layers around the service that you're building. So open source is a jobs to be done problem. Open source also builds trust with customers. We really want to become this core platform that people use to build AI native applications on.
Bob, welcome. You are the CEO for Weaviate, which is an exciting company in the exciting field of vector databases. The company has raised $67 million in venture capital money. For those who count, your Series B company. And I thought a good place to start would be to do a level set around this emerging architecture around, whether that's called the modern AI stack or whatever, that's mostly focused around this concept of RAG, for Retrieval-Augmented Generation. Can you help paint a picture of what that looks like and where do vector database fit in?
Yeah, sure. So first of all, thank you for having me. Thank you all for being here. So RAG is an abbreviation of Retrieval-Augmented Generation. So it's kind of the name kind of describes what it is, right? So you augment the generation of the generative model by retrieving something, right? And RAG was the first unique use case, if you will, that emerged around the ecosystem of vector databases. So I'm at this for quite some time already. It's like before it was cool, basically. and back then, most was like focusing on what we call like better search or better recommendations. But RAG was something really new that emerged. And what RAG basically does is that the moment that you have a generative model, but you have your own data, right? And you want the model to generate something based on your own data, you somehow want to feed that information into the model. And this is where the vector database plays a role. And because based on vector search or hybrid search, you can retrieve documents from the database, you can inject them into the generative model, and then you can just generate something based on your own data. That is something that works better than fine-tuning, for example, because if you fine-tune, then you're still dealing with potential hallucination. Fair enough, with RAG that's possible too, but it's less risky. But what's interesting to mention is that the way with we, I mean like everybody in this room work on this stuff, are doing RAG right now, is actually pretty primitive, right? So we retrieve the data from the vector database, we inject it in the prompt, but a lot of exciting work is happening that the model actually knows how to retrieve based on the vector embeddings from the database itself. So the model and the database start to weave, no pun intended, together.
Okay, and while we are in the definition part of this conversation, maybe define what an embedding is to make this interesting to a broad group.
Yeah, sure. So an embedding is if you will, a geographical representation of your data. So I see some faces now going, huh? So a very easy way to think about it, if this is new for you, is that the example that I always give is based on a supermarket. So you say like if you have a supermarket and you look at the map of a supermarket, you have a 3D representation of stuff that's in the supermarket. And if you have a shopping list and the shopping list says, I need apples, washing powder, and bananas, you kind of know that if you are looking at apples, that the bananas are closer by than the washing powder. And you know that if you walk to the washing powder, that you move away from the fruit section. And vector embeddings are a way, especially not only in language, but language is the use case we see the most right now, is a way to represent how things are different from each other. And that's just by, I mean, if you want to, we can double click on how that's done. But it's a way of describing similarity. And the power is set in the fact that if you stored a data object of, let's say the Statue of Liberty, that based on the text, you knew that the distance between, for example, Paris and the Statue of Liberty was bigger than New York and the Statue of Liberty. That now the thing that we could do is that we could retrieve data from the database where we did not have exact matches or keyword matches. And that was like the unique thing that we saw based on vector embeddings, right? So these dimensional representations of where and how we distort the data, basically.
So to play it back, you have a large language model, which is your AI engine, and then RAG is the system that enables you to, at query time, check the results against your data, and your data is stored in the vector database. And the way to get the data into the vector database is through the embedding models. Is that fair? Or is that too simplistic?
That's fair to say. And the common way that developers do that today is that they store the actual data object combined with one or more vector embeddings in the database. So it works. The UX is like a traditional database, but it's purpose-built to deal with these vector embeddings. So the uniqueness sits in the index.
And the embedding model space seems to have gone from something that very few people talked about that seemed like a solved problem, this idea of transforming your data into a format that vector databases can understand. That went from what felt like a solved problem to like a very hot space in the kind of an LLM stack, including a race to the bottom in terms of price. What do you think that is, and what is happening there?
Oh, that's very simple. It's we're now in this transition from the people who were trying it out, building POCs, prototypes, the usual stuff, and now they want to go into production. And the thing to bear in mind is that if you have an embedding of 768 dimensions versus 1536, that's like you need double the memory to store the letter, right? And if you do a POC with like 100 or 1,000 or 1,000,000 data objects, that's fine. If you now scale that up to hundreds of millions or billions, it gets expensive quickly. So a lot of work has been happening, one, in retrieval speed, because again, if you want to index 10,000 documents, you can wait. If you need to index 10 billion, you need speed. Speed becomes of the essence, so that's one thing. The second thing is work in the models themselves. So can we lower the size of dimensions that we need to store? And the third thing that sits a little bit in the overlap between the database and the models itself, and that has to do with compression algorithms, binary representations, the whole shebang, just to make it as easy as possible to run the stuff in production.
So everyone these days talks about RAG as this kind of problem, like the solution to the problem, like hallucination and all the things. And a lot of people talk about it almost like a fait accompli, like it's something that everybody has agreed is working. What's your assessment? Like how is it really working? What are the issues? And how do you evaluate if it works in the first place?
So it's a first step. So what's very important for people to know, if you run a database company, then the big question that you always ask is like, and people like yourself, what you guys always ask, so what's the unique use case, right? And then if in the beginning, yeah, we can do stuff with search and recommendations, look how cool it is, but yeah, we can see, but what's the unique use case? So the moment, so RAG is quite old, old in the sense of how things are young and old in the space of AI. So it's a relatively older concept. For those interested, you can actually, if you go into the Hugging Face library, you can see first iterations of it. It's very, very interesting. But so when ChatGPT came to the scene, a lot of people were like, we want to do this with our own data. And people are like, hey, it's great to use vector database for this because the input queries are often not fully working for keyword matching. So this was like a beautiful use case for the vector database. And it's not always right because it's like the pure vector search, so vector search alone is often not enough, right? So that's like stuff like hybrid search, but we might get to that. But not only that, also RAG is just the first step in new things we can do with vector databases. So one thing that I'm extremely excited about is something that we call generative feedback loops. So it's based on RAG with the vector database, but what it does is that it stores data back into the vector database. And we have on our website, we have a blog called Generative Feedback Loops, and it's based on Airbnb data. And what you see in the data set is that you have Airbnb data, but there's missing information. So descriptions are missing or stuff is incorrect. So what you basically do is you query, in this case, Weaviate. It runs through a generative model and it says, hey, this is Airbnb data, but it's incorrect. Fix this for me. It fixes the data or it fixes the description, creates a vector embedding and stores it back in the database. So now the model itself starts to interact with the database. So just give it a prompt, if you will, like there could be a problem like, hey, there's something wrong with my data, there's an issue with my data, fix it for me. And that is the thing that I'm like super excited about, and I would not be surprised if this year, 2024, is the year of generative feedback loops. Because this is really a seismic shift in the database landscape. It's now not people directly interacting with the data, but is you give a assignment to the model, and the model knows how to interact with the vector database. And they do that by using vectors. So the point I'm trying to make is RAG is beautiful, it's a first step, but it's one directional. And we're now gonna go to looping it, so making it bidirectional, if you will. And with the multimodal models, we even have like multiple directions that you can go into. So it's exciting times.
So that's RAG as an emerging architecture for generative AI. Let's get more specifically into what you guys do at Weaviate. So in particular, hybrid search seems to be something that you have spent a lot of time working on. What is it and what are the benefits?
Yeah, so what's important to know is that Weaviate is open source. And if your database is open source, you get something beautiful, which is called a community. And the community starts to work with your database and they tell you what doesn't work. And that can be, on one hand, that can be just related to operational issues, but it's especially interesting from use case issues. And one of the things that people started to tell us, right, were actually two things that people started to tell us was this. Like, one, they said, vector search is amazing, but sometimes it's not enough. And in a bit, I'll share with you what that is. And the second thing that they said, like, these vector embeddings, we need to work with these models. It's like, not everybody knows how to do that or how to efficiently do that. I mean, there are like a lot of developers, like the people in the room here, that are like very smart that know how to do that. But there's not everybody knows that, right? Or people want to just speed up, their development. And so we learned these two things. And so back to the first point. So if you have a query that says, for example, let's say that you have a data set with customer support tickets. And you say like, how was customer support ticket ABC123 handled? The query itself is ideal for vector search. But matching on ABC123 is horrible. That's like the model is super bad at that. Why? Because it was never trained on your knowledge base. So what you do with hybrid search is that you kick off simultaneously two queries. So one, the vector search query, a score comes out. But with hybrid search, you do a BM25 search. That works very well for ABC123. And it merges these results together. So now it basically upvotes, if you will, re-ranks based on the tickets that you have in your system or in your database that are related to ABC123, and then they organized based on the semantic query that you have. Now, what does that have to do with the second part? If you build a vector database, you can take two approaches. Approach number one is you say, people need to generate their own embeddings, and they just query the database based on the embeddings. You could do that. I mean, you can do that in Weaviate too if you want to. But what we figured out is that if we incorporate the models in Weaviate as well, so it doesn't matter if it's an OpenAI, a Cohere, an Anthropic, or an open source model, doesn't matter. If we incorporate them, we can bring the whole hybrid search feature out of the box. Because now you throw just the text at the database or the image at the database, and the database figures out where it needs to create embeddings, and it figures out where it needs to do the hybrid search. So the reason we built that is because the community told us the most optimal way for us to build applications is actually if we can do that out of the box. So that's why we have that.
What are some other features that you would want to highlight that make Weaviate special?
Oh, thank you for giving me. So the first thing is the deployment model. So it's because we live in like 2024 now, we've learned from all these amazing existing infrastructure companies that like the generation before us, like what the most optimal way is how people want to use database. So you can use Weaviate serverless, BYOC, to the marketplaces, embedded, open source in Docker, open source in Kubernetes, you name it. However you want to use it, you can use it. That's one. The second thing is that you can store the complete data object. So it's very common to what you're used to from existing databases. But now it has like, it's really focusing on this, what we call AI native stack first. But the third one, and that's by far the most important, is that we've built the database to help you build AI native applications. So what we mean with that is like, if you're building something and you want to sprinkle some machine learning stuff over your application, that's great. I mean, you can use Weaviate too, but you can do it in other ways too. But if you say, no, I'm building something that it has like AI at the core, we give you all the tools and all the infrastructure to build it out of the box, to get you up and running in minutes. And that is the core value prop, if you will, of Weaviate. How did I do? Was it good?
Yes.
Thank you.
How about security? It seems to be something that you guys spend a lot of time on.
Well, so I mean, security is the short answer is yes, but the more elaborate answer is that
No, we hate security.
exactly, yeah. No, but that would be funny though. No, but so what starts to happen is that people start to move into production, and then you get just everything that you would expect from running in production, like, hey, can we actually separate tenants? What kind of security features do you have, and so on, backups, and so on and so forth. So the more basic things that one would expect from a core piece of infrastructure. Again, this is really led through a community of users and customers. They just say, hey, great, we want to move to production, but we really need this one thing. And then great, and then we add it to the roadmap, community upvotes it, and that's how we build it.
You have a lot of integrations. One that caught my eye in particular is Confluent. Is the idea that RAG needs to be increasingly in real time? Real time is this area that like for the last 10 years, people have been saying, this year is the year of real time. And then the next year, no, this year is the year of real time. And it seems to be happening. But do you think RAG accelerates that need for real-time data?
So I'm kind of laughing because what you're saying with Confluent is of course amazing in real-time stuff, but the bottleneck is now these models. So these people at Confluent are waiting. It's like, when are you guys real-time, right? When is the serving real-time? But on a serious note, why this becomes so interesting, at some point we saw it started for Weaviate in an uptick that we saw community contributions to our Spark connector. That's how it started. And what started to happen was that, and this is an example of AI native, is that a lot of companies said just all the data that's going to come in, doesn't matter if it's like transactions or text objects or whatever you can think of. We're not only now going to send them through our streaming pipelines as JSON objects, but we're going to attach these vector embeddings to them. Because now people don't have to run their machine learning model separately. We just run it, and if you need it, you can just use it with the right model. So that's why it's so interesting to work together with companies like Confluent, because more and more companies start to literally stream the data with pre-calculated vector embeddings.
The vector database space has been very exciting to watch over the last year, certainly a hot space, and there's a whole list of interesting startups. Just as this event, we had Pinecone, we had Chroma.
I don't know.
How should people think about the criteria to evaluate one vector database versus the other? And you can name names, which would be fun, or not.
So the no, so the first thing is this. So the for a long time we were waiting like when. So okay, no, let me rephrase. So the vector embedding is just a data type. So it's just an array of floating point numbers. I mean, you can store that in an old Oracle database, right? So, but the thing where it becomes interesting is the index. So the index in how you store and retrieve the information, you can do it in memory, for speech, you can do it on disk, if you want to optimize for storage and those kind of things. So what we start to see now is that basically every database under the sun supports vector embeddings. That's a great thing. That's like for me as a vector database founder, that's like a champagne problem, right? Because that means that people see the value in using vector embeddings. So now, if you look at the vector databases space, it's like you get to these purpose-built databases, right, that are really good at dealing with these embeddings first. So maybe if you're building something small or you're trying something out, you might want to store them somewhere else. That's fine, right, because it became a universal data type. Now you can make a distinction between that you're saying like, okay, do we just want to care about these vector embeddings, how we store them? Or do we think a little bit bigger and do we think about the developer that wants to build AI native? So if you're building something, I would recommend thinking about, do we just want to store a couple of embeddings? Or do we need to have help building AI native from the ground up with model integrations, the embedding integration, that kind of stuff? And that is what we try to, solve. And I mean, there's another, it's like you also have libraries like Face, from Face or Meta, right? That's more a library to store embeddings in. There's certain use cases where that's great, right? But again, we really want to become this core platform that people use to build AI native applications on. And yes, at the heart sits the vector database, but that's not the endpoint. That's like that's the starting point where people build on top of.
And I suspect the answer is going to be the same, but what do you make of the more general purpose databases entering the field of vector databases, MongoDB in particular?
I mean, so that goes back to my previous answer. I mean, good for them, right? It's great that they've seen the light too. It's a bit late though, but it's like good for them. So
shots fired.
Yeah, yeah. So, but on a serious note, it doesn't really matter because the thing is that in the end, what's important is how you help developers be successful in what they're building, right? And so MongoDB is amazing for developers building web apps and that kind of stuff. So if these developers want to do something also with vector, it's great, good for them. And the same thing is like, I don't know, if you think about Snowflake is great for like your OLAP use cases. We are amazing if you want to build AI native applications. And that's how we want to be seen top of mind to the developers. And yes, the vector embedding and this vector storage sits at the heart of that, but that's just that's the core of the onion, right? And all the layers around that is the tooling, are the integrations, are the model integrations, are the developer experience, and so on and so forth to help you build AI native applications. So them entering the field, great, because that shows that there's a market fit. And we specifically focus on those who want to build AI native.
Talking about customers and go-to-market for a second, what are some like fun examples of what you've seen people build with Weaviate? Some interesting use cases.
So the use cases are still pretty much. I mean, we see some clustering right around e-commerce and those kind of things, but it's still very much all over the place. I think so. let me give you two examples of things that I'm very proud of, right? So just that come to mind. One are just tools that I use myself, right? It's kind of nice that if you see like a blog from Stack Overflow saying that they use Weaviate, oh, thank you, I use that, right? That's one thing that I'm proud of. And the second thing that I'm proud of is if you are a core part of technology, new applications that people are building. I mean, I came in today and this gentleman came up to me and said like, hey, we're using Weaviate. It's a core part of our stack. So great, that's wonderful, right? We saw it with, Instabase, for example, right? How they rewrote some core infrastructure with Weaviate. So those kind of things is something that I'm extremely proud of. That's just really cool to see. And it's like so it's a combination of tools that I use myself that I'm very proud of, or just that it's just such a dream coming true that you're helping people to be successful with the businesses and applications that they are building. That's surreal. That's amazing.
What's your sense of the current state of the market? You mentioned earlier in the conversation, people starting to scale with a lot more objects. Where are we? Are we still super early and people are just starting to deploy, or are you seeing some evolution?
Yes, I mean, people start to deploy, but the case that people are deploying are kind of lagging at the really the new use case. So the most deployments, like the billion scale deployments, are very much just similarity search, right? And then the next wave now is like the hybrid search cases, and then the big use case after that, the RAG use cases. And I hope that later this year we see those generative feedback loop cases. So really those core AI native cases. But it's as one would expect, the core production cases lag a little bit on what people are experimenting with. So that's where we are right now. But it's still, I mean, may I ask who never heard about a vector database before they came to this event? Okay, so we still see, okay, this is so funny. It's like, this is less hands than I actually expected.
That's all the people that didn't dare raise their hands.
Exactly, but the nice thing is like, so we still need to have a lot of work to do when it comes to the education, right? We need to help people to understand how they can build with these kind of databases. So it's like, it's still, long story short, it's still early days.
So you're very much an open source company. It was an interesting question for me to hear how people think about how much do you put in the open source versus how much you put in the commercial product.
So open source is a jobs to be done problem. So the database itself, you're not selling the database. What you're selling are the services around the database. So we create proprietary software that is like our serverless offering. Those are BOIC things that has to do with monitoring, with the whole shebang, right? And around that with a graphical user interface, Weaviate apps, that kind of stuff. So the core database is open source, and it's a way for people to tinker around with what's happening. Important to know, open source also builds trust with customers. It's not a black box. You can just be super transparent about what you're doing and how you're doing it. So that's the role of open source. But the job to be done, the value to be captured, does not per se sit in the open source technology itself. It sits in the layers around that. Somebody today forwarded me a Harvard article. It's called like the value that open source is creating or something. I'm not sure if you've seen that. It was like 2 weeks ago. And the article is super interesting. The article is about, and I'm saying this from the top of my head, so the numbers can be off a little bit, but they said like how much the economy is thriving on open source. And they also made a calculation that if open source would not exist, how much companies should invest in rebuilding it. And so I believe that I saw in the abstract of the article that they estimated that the value of open source to companies right now is $8 trillion, right? And if companies would have to rebuild it themselves, that would 3.5 times be that number. I might be slightly off that I don't remember it correctly, but the point is, what you're doing, if you're building 8 trillion in value with all these open source companies, you can capture some of that value in the layers around the service that you're building, right? So that's basically the premise of open source, that the cake is so big that you just try to figure out how you can capture value of that cake. So it's like a small cake and you eat all of it, or you have a big cake and you eat a little bit of it.
So maybe to close, because then I want to open up to people if they want to ask questions. Tell us more about the companies. Presumably you're recruiting and all the things, but tell us maybe the quick version of the founding story, what you did before, how you started it, and give us a sense for like how many people you are, what you're recruiting for, that type of stuff.
Oh, sure. Oh, so yeah. So I'm working in software for a long time. So that's because I'm born in '85. So in 2000, when I was 15, we just got an internet connection. And there were like people, they were like, we need a website. And I was like, I can build you a website. So that's kind of how I started. So I'm Dutch. So then you go to the Chamber of Commerce and you start your little company. And I was time to go study. So I studied music, as one does. And after that, I just continued working building my software consultancy business. And in that capacity, I was working for a publisher. And this is 2015, and they were looking for new ways to build new products based on the articles that they were selling. And it was like, hey, there's this new thing with machine learning. Back then it was GLAV and fast text, single word embeddings. Maybe we could do something with it. So I started to play around with it. I started to vectorize a little bit of these things. It was just back then it was just a CSV file with words and embeddings. And I was like, hey, there's something in here. There's something here. And then I went to Google I/O in 2016. I fact-checked this, so this is actually correct, that Sander Pichai said, we're going to move from mobile first to AI first. And I was like, I know what they're doing. They're using these vector embeddings to vectorize, I guess, web pages and that kind of stuff. So that was when we started Weaviate. And back then, we didn't call it vector, nobody called it database back then. So we started to look, and more people seem to have this idea, right, about you can do something with vector embeddings. And then all of a sudden, it took off, and OpenAI they had a search endpoint that they deprecated. This is pre-ChatGPT, so they deprecated that search endpoint, and said, well, you just can buy our embeddings. So there are 3 ways that you can index them and search through them. They said, one is Face from Facebook, the other one is Weaviate, and the third one, I forgot the name of the company. But that they had on that list. And then I can tell you, if OpenAI adds you to their website, everything goes up. And then you had the whole ChatGPT thing, and then people were like, we want to do their own data, and then it was through the roof. So, but I can tell you, I mean, it was a long journey. This was not overnight. Oh, and by the way, to answer the rest of the question, so we are 100% remote. We have everybody from San Francisco to in Berlin. We're like 60-some people, always interested, to hear from interesting people. There are like a couple of Weaviate people there. So Nick, Erica, say hi. So you can talk to them, and you can talk to me. So, Did I answer everything?
Yes, that was wonderful. Thank you so much.
Thank you.